Welcome back, ladies and gents. In this teaching video, I'm looking at 8.3 variable acceleration in one dimension. 8.3 represents chapter 8, section 3 of the Pearson A-level Maths Applied Maths Year 2 textbook. So I'm going to start this teaching video by going through some important facts. First of all, S represents the displacement, in some cases the distance. V represents the velocity, in some cases the speed, and A represents the acceleration. If we take the displacement and we differentiate it, we get the velocity equation. If we take the velocity and we differentiate it, we get the acceleration equation. Alternatively, the acceleration equation is given by the double derivative of the displacement equation. Now let's work backwards. We know that the reverse of differentiation is integration. If you take the acceleration equation and you integrate it, you get the velocity equation. If you take the velocity equation and you integrate it, you get the displacement equation. So that there is the important fact for this particular section. Here is exam style question 1. A particle P moves in a straight line so that at time t seconds its displacement from a fixed point O on the line is given by this piecewise function. So S can take on these three possible displacement equations dependent on the interval for t. Part A, find the velocity of P when t is equal to 2. First of all, t equal to 2 falls in this interval over here. So the displacement equation that we have to use is the first one. S equal 3 to the power t plus 3t. To find the velocity equation, we have to differentiate the displacement equation. So the velocity is given by ds over dt. This implies that v is equal to the derivative of 3 to the power t, which is 3 to the power t ln 3, plus the derivative of 3t, which is 3. Okay, when t is equal to 2, this implies that the velocity of the particle P is given by 3 squared ln 3 plus 3. We can clean this up and we can write v equal 9 ln 3 plus 3. So that is the velocity in exact form. We can put meters per second at the end. That there is the icing on the cake. Now in mechanics, we round to 2 significant figures or 3 significant figures. So let's round this one over here to 3 significant figures. If we do this, we get v equal 12.9 meters per second. Let's move on to part B. Find the velocity of P when t is equal to 10. Now t equal to 10 falls in the third interval for time. T is more than 6. So the displacement equation that we have to use for the particle P now is the third one. S equal minus 252 plus 96t minus 6t squared. We know that the velocity is given by ds over dt. Ladies and gents, this implies that the velocity will be the derivative of minus 252 is 0. The derivative of 96t is 96. Take away, the derivative of 6t squared is 12t. Okay, so we want to work out the velocity of the particle P when t is equal to 10. When t is equal to 10, this implies that the velocity is equal to 96 minus 12 multiplied by 10. Okay, so we can put this into our calculator and we get v equal to minus 24 meters per second in exact form. That there completes part A and part B of the question. Let's have a look at part C. Find the greatest positive displacement of the particle P from O. Right, so we've got 3 displacement equations. The first one is 3 to the power t plus 3t for this particular interval for time. We know that for this interval for time, if we were to put any of the values into this displacement equation, it will be positive and increasing. Second displacement equation is given by this one here, 24t minus 36, for this interval for time. If we take any of the t values over here and we put it into this displacement equation, we'll get a positive increasing output. And so what we can conclude is that the greatest positive displacement of the particle P from O does not occur in these 2 particular intervals. It has to occur in the third interval. Now, we're going to be using the third displacement equation, s equal minus 252 plus 96t minus 6t squared. We know that this is defined for t is greater than 6. We want to find the greatest positive displacement. Now, the displacement is a maximum when ds over dt is equal to 0. Okay, so if we differentiate the displacement equation, we get the following result. 96 minus 12t. Okay, so we have to set that equal to 0. Now we're going to rearrange and make t the subject. We've got minus 12t is equal to minus 96. And so t is equal to 8. So what we're assuming is that the displacement is a maximum when t is equal to 8. We can check this by using the second derivative test. So d2s over dt squared will just be the derivative of the first derivative. This was my first derivative. If I differentiate this, I just get minus 12. I know that when t is equal to 8, d2s over dt squared will remain as minus 12, okay, which is less than 0. Hence, s is a maximum when t is equal to 8. So to work out s max, we need to substitute t equal 8 back into the third displacement equation. So I've got minus 252 plus 96 multiplied by 8 minus 6 multiplied by 8 squared. Okay, so I can put this into my calculator to work out S max. If I put this into my calculator, ladies and gents, I get S max is equal to 132 meter in exact form. So the greatest positive displacement of P from O has to be 132 meter. Here is exam style question 2. A particle is moving in a straight line. At time t seconds where t is greater than or equal to 0, the acceleration of P is a meters per second, and the velocity v meters per second of P is given by this particular equation. K is a constant. The initial acceleration of P is 4 meters per second. Part A, find the value of K. So initial means t is equal to 0. So when t is equal to 0, the acceleration A is equal to 4 meters per second. Right, first of all, I'm going to take my velocity equation and find the acceleration equation. To do this, I need to differentiate my velocity equation. So A is equal to dv over dt. Okay, so we're going to differentiate the velocity equation. This implies that A is equal to, the derivative of 2 is 0, and the derivative of 8 sine kt will be 8 multiplied by the derivative of kt, which is k, so 8k. And we know that a sine differentiates to a cosine, so we've got cos kt. Right, so we're going to substitute t equals 0 into this and a equal 4 into this. So we have 4 is equal to 8k multiplied by k times 0 is 0 and cos of 0 is 1. This equation over here reduces to 4 is equal to 8k. Now we can divide both sides by 8, and if we do this we get a half is equal to k. Therefore, we've got k is equal to a half. That there completes part A of the exam style question. Moving on to part B of the question. Using the value of k found in part A, which is k is equal to a half, part B, find in terms of pi the values of t in the interval t is between 0 and 4 pi inclusive, for which the acceleration is equal to 0. So we've got k is equal to a half. We can put that back into here. So we have that the velocity equation is given by 2 plus 8 sine a half t. To find the acceleration equation, we have to differentiate the velocity equation. Okay, so the acceleration equation is given by the derivative of 2 is 0. If we differentiate a half t, we get a half. So 8 times a half is 4. So we've got 4, and the sign differentiates to a cosine. So we've got cos a half t. Now, we've got a is equal to 0. This implies that 4 cos a half t is equal to 0. Dividing both sides of this equation by 4 reduces the equation to cos a half t is equal to 0. Now we want to solve this particular equation for t is between 0 and 4 pi inclusive. First of all, we're going to transform this whole interval. Each element of this interval is going to be multiplied by a half. So if I do this, I get 0 times a half is just 0. T times a half is a half t. And 4 pi times a half is 2 pi. Okay, so now we're going to let x equal a half t. So we're solving cos x equal to 0 for x is between 0 and 2 pi inclusive. We can sketch the graph for y equal cos x, and if we do this, we get the following graph. This is the x-axis. We've got our cosine graph, maximum at 1, minimum at -1. Okay, so this part over here is 0, pi over 2, pi, 3 pi over 2, and 2 pi. Cos x is equal to 0 for x is equal to pi over 2 and x is equal to 3 pi over 2. So we have that x is equal to pi over 2 or 3 pi over 2. But what did x represent? Well, x was a half t. So we have a half t is equal to pi over 2, or it could be equal to 3 pi over 2. We want to solve for t. We multiply both sides of this equation by 2. We get t equal to pi 3 pi. So the values of t in the interval t is between 0 and 4 pi inclusive, for which the acceleration is equal to 0, is t is equal to pi and 3 pi. Part C. Show that 4a squared is given by this particular right-hand side. Okay, so we've got an equation linking a and v. V is given by this, a is given by this. What we want to do is call this equation 1 and this equation 2, eliminate the t's, so that our equation is linking the two variables a and v. How do we do this? First of all, in equation 1, we can make sine a half t the subject, and then in equation 2, we can make cos a half t the subject. If we do this, we can then apply the identity sine squared a half t plus cos squared a half t is equal to 1 in order to eliminate the t. Okay, so let's start off with equation 1. Let's make sine a half t the subject. So we've got sine a half t is given by v minus 2 all over 8. So this is equation 3. Second equation, let's make cos a half t the subject. So cos a half t is given by a over 4. We can call this equation 4. Now we know that sine squared a half t plus cos squared a half t is equal to 1. The next step would be to substitute 3 and 4 into this identity. So if we do this, we get the following result. V minus 2 all over 8 in brackets squared plus a over 4 in bracket squared is equal to 1. So if we square this fraction, we get v minus 2 in bracket squared all over 8 squared, which is 64, plus a squared over 4 squared, which is 16, equal to 1. Right, so now we're going to multiply the whole equation by 64 because we want a 64 within the equation linking a and v. So if we multiply the whole equation by 64, this term reduces to v minus 2 in bracket squared plus this term over here reduces to 4a squared equal to 1 times 64 is just 64. And now we can make 4a squared the subject. So 4a squared, ladies and gents, is given by 64 minus v minus 2 in bracket squared as required. And that there completes part C of the question. On to the last part of the question. Part D, find the maximum velocity and the maximum acceleration. So we know that the velocity is a maximum when dv over dt is equal to 0. Now dv over dt represents a, so a equal to 0. When a is equal to 0, we know that t is equal to pi and 3 pi. This was calculated in the previous part of the question. Okay, now when t is equal to pi, v is equal to 2 plus 8 sine a half, remember k was a half, multiplied by pi. If I put this into my calculator, I get exactly 10 meters per second. When t is equal to 3 pi, v is equal to 2 plus 8 sine a half multiplied by 3 pi. Again, if I put this into my calculator, I get 10 meters per second. Hence, the maximum velocity, v max, is given by 10 meters per second. Now, we also want the maximum acceleration. So, acceleration is a maximum when dA over dt is equal to 0. Now we know that A is equal to 4 cos a half t. This was shown in the previous part of the question. So dA over dt is equal to 4 multiplied by the derivative of a half t, that's 2. And we know that a cosine differentiates to a negative sign. So we put a minus at the front, sine a half t. Okay, so dA over dt is equal to 0, which means that minus 2 sine a half t is equal to 0. We can divide both sides by minus 2. And if we do this, we get sine a half t is equal to 0. So the acceleration is a maximum when dA over dt is equal to 0, which gives us the result sine a half t is equal to 0. Okay, we can work out the value of v for which the acceleration is a maximum. Substitute sine a half t equal to 0 into the velocity equation. So we know that the velocity equation is equal to 2 plus 8 sine, the k was a half t. The acceleration is a maximum when sine a half t is equal to 0. So if we substitute sine a half t equal to 0, we get 2 plus 8 times 0. This gives us v equal to 2. To find the maximum acceleration, we have to substitute v equal to 2 into the acceleration equation. So we can use the acceleration equation 4a squared equal to 64 minus v minus 2 squared. Right, so v equal to, we can substitute it in, we get 4a squared is equal to 2 minus 2 is 0, 0 squared is 0, so we're left with 64 minus 0, which is 64. Hence, a squared is equal to 64 divided by 4, which is 16. Now, when we take the square root, we must include plus or minus. This question is about acceleration and not deceleration. So, to find acceleration, we're going to take the positive square roots. So, a is equal to the positive square root of 16, and so a is equal to 4 meters per second per second. So, a max, the maximum acceleration, will therefore be 4 meters per second per second. Okay, so the maximum velocity of the particle P is 10 meters per second, and the maximum acceleration of the particle P is 4 meters per second per second. And that there, ladies and gents, completes part D of the question, and this exam style question. Here is exam style question 3. A particle P moves on the x-axis At time t seconds, the velocity of p is v meters per second in the direction of x increasing, where v is given by this piecewise function. So the velocity equation could be this or this, dependent on the interval for time. When t is equal to 0, p is at the origin. Find the distance of p from O when t is equal to 4. First of all, when t is equal to 0, p is at the origin. So the displacement s is equal to 0. We're going to be using this boundary condition somewhere in our solution. Find the distance of p from O when t is equal to 4. So to find that distance s, or you could say displacement of p from O when t is equal to 4, we have to integrate the velocity equation. So integral of v dt. Now t is equal to 4. This over here falls in this interval for time. And so the velocity equation that we have to use for the particle p is the first one. So v is equal to 10t minus 2t to the power 3 over 2. To integrate these two terms, we need to add 1 to the power, divide by the new power. So we have that the distance s, or you could say the displacement, is given by the integral of this velocity, which is 10t minus 2t to the power 3 over 2 dt. Okay, so we're going to add 1 to the power, divide by the new power in order to integrate these two terms. So if I do this, I get s equal 5t squared minus 4 over 5 t to the power 5 over 2 plus c, the constant of integration. Now to work out c, we're going to be using this boundary condition. When t is equal to 0, p is at the origin O, so s is equal to 0. We can substitute this into here. So when t is equal to 0, s is equal to 0. So we have 0 is equal to 0 minus 0 plus c. So we just have c. c is equal to 0. So in full, the distance, or you could say the displacement equation, is given by 5t squared minus 4 over 5 t to the 5 over 2. Right, now we can find the distance of the particle p from O when t is equal to 4. Simply substitute t equal to 4 into the distance, or you could say the displacement equation. So when t is equal to 4, the distance s is given by 5 in bracket 4 squared minus 4 over 5 in bracket 4 to the power 5 over 2. So we can put this into our calculator, and ladies and gents, we get s is equal to 54.4 meters. So the distance of p from O when t is equal to 4 is 54.4 meters. That there completes exam style question 3 and this particular teaching video. If you found the video useful, please don't forget to leave a comment, leave a like, turn on your notification bell so that you receive notifications every time I upload a teaching video. And don't forget to subscribe.